Hi, let's start with the bell ringer. What I would like for you to do is fill out the Venn diagram as much as possible. So what we've done first is filled in all of the information that required very little thinking. The next thing is to figure out where does the 28 students belong. Well, it says 28 students took French or math, so the 28 belongs in the or part. The next thing that we should focus on filling out is the and statement. If we were to take the 20 French students and the math students and add them together, that would give us 45 people. But 45 people is too much if there are only allowed to be 28 in that area. That means there were 17 people that were counted twice. And they belong in the and section. Let's finish French only and math only, which means 3 students took French but not math, and 8 students took math but not French. Next, we need to figure out our neither. If 28 were counted in French or math, that meant that 42 were not. To answer the first question, what number of students took both a French and a math? That is 17. The next, if we're looking at a junior who is randomly selected, what is the probability that the student took French but not math? First, let's figure out our denominator. If we're looking at a random junior, how many juniors were there? We're looking at our total population of 70 juniors. Next, we need to determine how many students took French but not a math. And looking at our Venn diagram, that answer is 3. Now we're looking for if a French student is randomly selected, what is the probability that that student also took a math class? Let's focus on the denominator. What is our sample space? So we are only looking or talking to the 20 students who are in a French class. Now, what's the probability that those students also took a math class? What is the numerator? That would be the 17 that were in our and category. Now let's look at a prediction. Remember that the general formula for prediction is the expected number would be the probability of that event times the new population. So first, we need to find the probability of a junior that took a math class but not a French class. Let's consider the denominator. We are back to the original 70 students. Now, how many students took math but not French? That would be 8. You don't have to, but I will always simplify my fractions. Now let's find the expected value. We would expect that 74 students out of the 650 would be taking math but not French. So let's review today's objectives. I can find the probability of independent and dependent events. An independent event is when one outcome does not affect the outcome of another. In other words, you're resetting the problem back to its original state. In order to calculate the probability of the independent events, you find the probability of each event separately and then multiply. Let's take a look at an example. Given a bag containing 3 blue, 5 green, and 4 yellow marbles, the first question I have is, how many total marbles are in the bag? That's right, there are 12. So, what is the probability of selecting a blue marble, replacing it, and then selecting a green marble? First, let's focus on the blue marble. What is the probability of selecting a blue marble? The probability of selecting a blue marble is 1/4. So we took the marble out, and then we are going to replace it. Now, let's find the probability of selecting a green marble. Since there are 12 marbles still in the bag, the probability of picking a green marble is 5/12. Now let's find this probability of these two independent events together. According to our rule, in order to find the probability of both things happening, you multiply the two separate probabilities. So that's 1/4 times 5/12. So the probability of a blue and a green would be 5/48. Let's try looking at the yellow marbles. What is the probability of selecting a yellow marble, replacing it, then selecting a yellow marble again? Let's find the probability of finding one yellow marble. The probability of finding one yellow marble is 1/3. Now we're taking it out of the bag and replacing it. So we have reset the bag to its original condition of 12 marbles. The probability of selecting a yellow marble again is the same, 1/3. So what is the probability of selecting a yellow and a yellow? The probability is 1/9. So these are independent events where we basically reset the problem back to its original set of conditions. Now let's take a look at some dependent events. This is when one outcome does affect the outcome of the other. So let's go back to our bag of marbles. There are still 12. What we need to do is find the probability of the first event times the probability of the second event given a special condition. What does that mean? Well, first, let's find the probability of selecting a blue marble. That probability is still 1/4. Now, we are going to take the marble out and not replace it. We now need to figure out the probability of selecting a green marble now that a blue marble has been removed. The shortcut way of writing that is the probability of green given, that's what that pipe up and down line segment means. So green given blue. So what is the probability of green given blue? Out of the 11 marbles that are left, 5 are green. So now let's answer the question, the probability of blue and green. We multiply these two probabilities together and get 5 out of 44. Let's take a look at what happens with the yellow marbles. We are back to our 12 marbles. What is the probability of selecting a yellow marble? The probability of selecting a yellow marble is 1/3. Now we are going to take that marble out of the bag. And now find the probability of finding a yellow marble now. So we need to find the probability of a yellow marble given that one of the yellow marbles has been removed. Let's focus on the denominator. There are 11 marbles left. Now, how many of those marbles are yellow? 3. So the probability of choosing a yellow, given that a yellow has already been removed, is 3/11. What is the probability then of finding a yellow and a yellow? The probability is 1/11. Let's take a look at some problems that aren't as obvious. Before we can choose what kind of calculation we're going to do, we need to figure out if the situation is independent or dependent. In general, there are 8 nickels and 10 dimes in your pocket. So there are 18 coins in your pocket. You randomly pick a coin out of your pocket and place it on a counter. We need to ask, does this reset the problem back to 18 coins in our pocket? No, which means that we're changing the original situation, which makes this question a dependent event. Now, in order to find the probability that the first coin is a nickel and the second is a dime, I now know what kind of calculations I need to make. I am going to need the probability of finding a nickel, and I need to find the probability of picking a dime, given that a nickel has been removed. So let's try finding the probability of a nickel. Now, let's find the probability of choosing a dime, given that a nickel has already been removed. Now let's find the probability that the first coin is a nickel and the second is a dime. The probability of a nickel and a dime would be 40 out of 153. Looking at problem B, you randomly pick a coin out of your pocket, put it back in your pocket, then you randomly pick another coin. Is this independent or dependent? Putting the coin back in your pocket means you are resetting the problem back to its original 18 coins in your pocket. This is an independent event. So what are the 2 probabilities we will need? We will need the probability of a nickel and then the probability of a dime. The probability of the nickel has not changed. There are still 8 nickels out of 18, which simplifies to 4/9. What is the probability of a dime? There are 10 dimes out of a possible 18, which simplifies to 5/9. Let's answer the question, what is the probability that the first coin is a nickel and the second is a dime? The probability of a nickel and a dime would be 20 out of 81. You guys did a great job today. Please make sure that you fill out your exit slip and then get the assignment that is due tomorrow. Bye.